Okay, let's finish off the rest of these problems. So we're looking at the same information, except that well, we're just doing the problems for it. So watch the previous video if you have questions about where these numbers are coming from. So I'm looking, this problem looks at the pi over 4. So pi over 4 is going to be right here. So I'm dealing with the square root of 2, comma the square over 2, comma the square root of 2 over 2. So that's going to be pretty easy when I'm looking at doing the sine, cosine, and tangent. Cosecant, secant, and cotangent. Well, the sine, both of the numbers were square root of 2 over 2, and so it doesn't necessarily matter, but technically the second one is the one that we're using. So I've got the square root of 2 over 2, and then that's over 1 because it's y over r, and then nothing happens with that when I divide by 1. Well, cosine is exactly the same thing because the numbers are exactly the same, so I get square root of 2 over 2. This time, on tangent, I'm going to take y over x, and so I get the square root of 2 over 2 divided by the square root of 2 over 2. Well, anything divided by itself, and you could go through and do all the extra work for it, but anything divided by itself is going to give you 1. So a tangent of 1 at 45 degrees. Well, that's pretty nice for cotangent because when I flip over 1, I still get 1. Okay, no real work necessarily goes into that. Okay, good thinking though. Good thinking goes into it. Cosecant, square root of 2 over 2. When I flip that over, I get 2 over the square root of 2. I can't leave it like that. I need to multiply both top and bottom by the square root of 2. And when that happens, I'll go back to a new page here. Well, when I flip that over, I get 2 over the square root of 2. Well, which means I need to multiply the bottom by the square root of 2 and the top by the square root of 2. So I get 2 square roots of 2 over the square root of 4. The square root of 4 is 2. The 2's cancel, and I get the square root of 2. Notice what happened. Last time we had 3 over the square root of 3. This time we have 2 over the square root of 2. Last time it came out to be the square root of 3. This time it comes out to be the square root of 2. Okay? Make sure that you're looking for patterns. Math is all about patterns. That's what we're looking for. Okay? Don't make yourself have to do all this work every single time. Okay? Secant is the same thing. 2 over the square root of 2. When I simplify or rationalize that, I get a square root of 2. Cosecant. Cosecant is the inverse of sine. We took a look at that one already. Part C. The theta is pi over 2. So I go to the unit circle. Pi over 2 is up here, so I have x value of 0 and y value of 1. So I go back to my problems here. X value of 0 and y value is 1. So when I do sine, that's equal to y over r. So that's 1 over 1, which is 1. Cosine is equal to x over r. X is 0, y is 1, so I get 0. And tangent is y over x, so that's 1 over 0, which is undefined. Do not write 0. Tangent of theta at pi over 2 at 90 degrees is undefined. So then I want to do the inverse trig functions, which is cosecant, and then cosine, and cotangent. When I flip over 1, that's not so bad. Okay, we get a 1. When I flip over 1 divided by 0, or 0 divided by 1, I get 1 divided by 0, which is undefined. Okay, here's where this becomes a little bit tricky. You need to be writing these out and actually flipping them over, because just because tangent is undefined doesn't mean that when I do cotangent that it's undefined. It actually comes out to be 0. Okay, and so I did cosine was 0, became undefined. Tangent was undefined, became 0. Another pattern. Lots and lots and lots of patterns in trigonometry. Okay, go ahead and find them. They're magical. D, we're looking at theta equal to 0. So go back to the unit circle. Theta is equal to 0. That's this one over here. I didn't want to erase. So this one over here. So I have an x value of 1 and a y value of 0. So when I come back to the problem here, I've got an x equals 1, y equal to 0. So I'm doing my 6 trig functions. Sine is y over the radius, which the radius in this problem is still 1. So I've got y equals 0 over 1, which is 0. Cosine is x over the radius, which is 1, so I end up with a 1. Tangent is y over x, so that's 0 over 1, which is 0. When I do a cosecant, I get 1 divided by 0, which is undefined. When I do a secant, I get 1 divided by 1, which is still 1. And when I do cotangent, I get 1 divided by 0, which is also undefined. Okay, so we start following these rules a little bit, finding places that, that these are undefined. So I have 2 pi over 3, last one. 2 pi over 3 is too far down. 2 pi over 3 is over here. So 2 pi over 3, I have negative 1/2 and square root of 3 over 2. Negative 1/2 and square root of 3 over 2. So let me just extend this page so we can get sines and cosines in here, along with tangents. And so you can see that, this ultimately becomes just pulling out information from the unit circle. So sine is square root of 3 over 2 over 1, which is the square root of 3 over 2. Cosine is negative 1/2 over 1, which is negative 1/2. Tangent is square root of 3 over 2, all divided by negative 1/2. Well, when I do that, the work for it, I'll do the work, eventually I won't. Divided by negative 1/2. Flip and multiply. 2's cancel, and I get negative square root of 3. They cancel and become 1s. On top I get negative square root of 3. You can put it over 1 if you want, but negative square root of 3 is the tangent. Cosecant. So when I go through and do cosecant, I'm flipping over 2 and square root of 3 over 2, so I get 2 over the square root of 3. When I rationalize that, I get 2 square root of 3 over 3. Okay. Secant, when I flip over negative 1/2, I get negative 2 over 1. Notice that I did not change the negative. It's still negative. Secant is negative because we went to the left to find this point. Cotangent, when I flip over negative square root of 3, I get negative 1 over the square root of 3. I need to rationalize that denominator. We did that one already. I end up with negative square root of 3 over 3, which gives me the cotangent. Okay. On the back here, example 2, determine the exact values of the 6 trig functions of the angle theta at the point 3 over 5, comma, negative 4 over 5. There's 2 ways to look at this. One would be that this is x comma y. Okay, so that's the point, and that's fine. You can do that. If you're thinking about it being in the unit circle, then that's okay. If you wanted to, you could also think about this like this is not x comma y, but cosine comma sine. And if you think about it as cosine comma sine, then this problem becomes a lot easier because what I end up having is 3 over 5 being x over r, and so the radius becomes 5, and it helps me to draw a triangle if I needed to. Okay, and so this is the way that I want you to start thinking about it, but if you thought about it as x comma y, just like the last points we were doing, you could do that too. Okay, if you go back and you notice that all the points that we put for sine and cosine just came back to be what the x and y ordered pair were. So cosine was x, sine was y. That kind of is an easier way to take a look at these. So cosine and sine, we have those already then. So this is 3/5, this is negative 4/5. And we can do the cosecants of those and the secants of those by just flipping those over. Those are the exact values of those 6 trig functions. Okay? This is out of the unit circle, but using the same idea. Okay? And that's kind of where we're transitioning to into 1.3 using right triangle trig. The tangent then is the sine over the cosine. Okay? But if you again went back to thinking about this as y over r, what ends up happening is if I do take that tangent and I do negative 4/5 divided by 3/5, negative 4/5 flip and multiply, 5s are going to cancel and I get negative 4 over 3. Okay? So we said that the tangent was y over r, or y over x, and so if I look at this sine value as y over r, and this cosine value is x over r, the y is negative 4, the x is 3, and I get negative 4/3. Okay, so whichever way you think about it, it doesn't necessarily matter, but there's 2 different distinct ways to think about it. And then when I do the cotangent of this, I end up flipping that over, and I get negative 3/4, and that's perfectly fine too. Okay, so keep that in mind, that all of these things have many multiple ways to start thinking about them. Example 3, using your calculator. I still can't get that TI to come up here on the screen, thanks to wonderful Windows 7. But you can use your calculator to do this. The sine of negative 2, you're just going to type that in. Okay, so go ahead and just type that in. Cosine of 196 degrees, you're just going to type that in. Tangent of 5, you're going to type that in. What you have to be careful of is deciding if you need to be in radians or in degrees. Okay, and so this is in radians, and so you have to go to mode and make sure that it's in radians. This is in degrees, and so you have to go to mode and make sure it's in degrees. This is in radians, go to mode, make sure it's back in radians again. Okay, and you have to be in the correct one in order to get the right answer. Okay, I'll put the right answers up here in a second. The cosecant, this is 1 over sine, so first thing is that you have to know, make sure this is in radians. Okay, so go into mode and put it in radians. Cosecant is 1 divided by the sine of pi over 5, pi divided by 5. Okay, so make sure that you put that in as 1 divided by sine of pi over 5. Some calculators you might have to put parentheses around this. Okay, so, but check your answers with the answers I'm going to give you here in a second. Again, with secant, this is in radians. There's no degree symbol, so we assume it's in radians. It also has a pi, so that's kind of a dead giveaway for us. Make sure you're in radians. Secant is 1 divided by the cosine and so you should make just do that again on your calculator. Here's the answers for that, so you can double check, make sure that that your calculator is doing what you want it to do. When you take a look at these answers, there's a few reasons why yours might be different. Number 1, make sure that you read the directions, round your answer to 4 decimal places. If you're not reading the directions and rounding properly, that could be an issue. So make sure that, that's the first thing that you want to look at here. Technically, this has a 0 at the end that I didn't put to 4 decimal places. In fact, I didn't do any of these to 4 decimal places. I only did them to 3. What was wrong with me? This should be 3.3805. That one's to 4. 1 divided by sine gives me 1.701 and a 3 at the end here. Now they should be right. You should have 4 decimal places. Read the directions, Mr. Wheatman. Okay, so check that. The second thing, make sure you're in the right mode. Okay, so go into mode and make sure you're in radians or degrees. Third thing, if you don't use the symbol pi, which is on your calculator, which is above the caret key, just below the clear, and go second pi. If you don't use the pi, you're going to end up with a different answer if you use 3.14. The calculator will do a few extra conversions after that. Third thing, make sure you're in parentheses. Fourth thing, make sure that when you do cosecant and secant, that you're actually doing 1 divided by that value. Don't use the sine inverse. Don't use sine -1. Okay, that's not what we're doing. We're not doing sine inverse. We will eventually. Right now we're doing cosecant, which is 1 divided by the sine. Okay, so go through, double check your answers, make sure that that you are able to do this on your calculator.